Hello everyone. In this video, I am going to share with you about one formula which is useful in the normal distribution, that is called the empirical formula, and it is a rule of 68, 95, 99.7, and it means it is saying that when your normal distributed data is broken down into one standard deviation, two standard deviation and three standard deviation. The area between one is 68%, and when we see how much area is covered between two standard deviation, that means u minus 2 sigma, 95%, and between three standard deviation it means almost cover 99.7, and rest of the zero point 0.3 will be on the both side of the tail. It is distributed. So we are going to see how it can be utilized in the problem solving. So let's see. So that here we don't need a table to see. We can directly implement this rule to evaluate some probability related question. So in this example, we have taken one question where there are 2000 freshmen in a college who took a diagnostic test, and the score were distributed normally with the mean 70 and standard deviation 5. So the question first, let us see the labeling part. So we know that this location is a location for the mean, which is a central value, and here the mean is 70, so we will write 70 here. And then next is that one standard deviation means minus 5 here and minus plus 5 here. When we do from the 70, we get the one standard deviation gap, and this becomes 65 to 75. And if we want to find out between the two standard deviation, in that case we will see that further when we subtract, it will be between 60 to 80. And the three standard deviation means three steps of deviation this side left and three steps to the right hand side, and we get a point. So the score of three deviation in the current question will be 55, and this side I'll get 85, and rest is the portion on the other side. Now if we want to use this empirical rule, so first of all let us recall again. The empirical rule says that 68% of the area is between this much portion, between 65 to 75, and 95% of the area is between 60 to 80, and 99.7% of the area is covered between 55 score to 85, and rest is on the both side. Now if we see this kind of situation, so obviously to implement it in the problem solving, what we can do, let us try to find out, because when we divide it into the standard deviation, we get these 8 portions. So if this 8th portion can be further bifurcated, it will be easy for us to solve a different questions from different range. So first let's begin with the middle part. Since from 65 to 75 we have a 68 portion, so if I want what is the area between 65 to 70 and 70 to 75, we know that both are symmetric. It means we can divide it by 2, and 68 when divided by 2 become 34 percentage, and this is also 34%, right? And in the same manner, if I am interested to find how much area is in the 60 to 65 and 75 to 80, in that case we can see that this 60 to 80 is 95, and when we delete this 868 in between, so these two portions are total area, and that is 27. And when we say 27 divided by 2, we can get a area between 60 to 65 and 75 to 80, and that is turning up as a, when we divide it, we get a 13.5, and this is also 13.5. And in the same manner, if we want to figure out what is this area and what is this area, means what is the area between 55 to 60 and what is area between 80 to 85, in this case also what we can do, I know that when we from 99.7, if I delete 95, we get the area of this two side, which is same symmetric. I'll get the area of both side total, and that will be 4.7. Get a 2.25 on one side, and this is also 2.25. So these are all in percentage we are talking about, right? And now we can see that some portion on the both side of this tail, we can say less than 55 and more than 85. Since we know that the total percentage is 100, and 99.7 is already covered between 3 deviations. So the rest of the portion will be only 0.3. So when we divide 0.3 into two parts, so we are getting 0.15 percentage, which is very less, and this is also 0.15 percentage, that we can see, right? And now we will use it for the problem solving. Let's see, there are certain questions we are going to implement it. The first question is demanding what percentage of the scores are between 60 and 85. So it means between 60 here, from here to 85 till this. So we are going to see, and we know that we have already divided into small chunks, but for this question what I can do, I know that from 60 to 80, this is a 2 standard deviation and the area is 95. So instead of adding, we know that it is 95, I have to just add this part, which is 2.35. So my answer will be 95% plus 2.35%, and this is turned up as a 97.35 percentage. So between 60 to 85, the total area covered is 97.35. So we can do like that. Next part is saying what percentage of score is less than 60. So less than 60 means less than this side, and since we know that less than 60 is covering 55 to 60 as well as the portion which is on the extreme end of the left, and this means we can add these two areas. One is 2.35 percentage and we can add this 0.15 percentage also, and the answer is turning up as a 2.5, and we get a 2.5 percentage, right? And let's see one more situation. What percentage of the score is greater than 85? So greater than 85 is very straightforward. It is only one part and it's 0.15 percentage. So we can get it like that. So in this manner, a lot of different scores between the deviation scores, if question is demanding, we can add and give the answer very easily when all the portions are in front of us, right? Now in the last two questions, I'm interested to find the number of students. So for that, first I will find out the probability and then we multiply with the total strength. It will give me the required strength. So they are saying what is the approximate number of students scored between 60 to 70. So first let us see what is the probability between 60 to 70, and then we can multiply with the 2000, which was the actual strength of the question. So here from 60 to 70, right? They are asking. So first let us see what is the probability in the percentage. 13.5% plus 34%. And when we will add it, it will be 47.5 percentage. Now if I am interested to find number of student, approximate students is equals to 2000 into 47.5 by 100, because we have to write the probability. So when we simplify, multiply this with the 47.5 and we'll get it as a 950 answer. And one more question, let's see for the numbers. Here they are saying approximate number of students scored between 55 to 60. So between 55 to 60, let's see first the probability. What is the values or percentage? So 55 to 60 is only this much. So we have only one case, that is 2.35, and that means approximate number of students will be number of students in this range is 2000 into the probability. So when I write down in probability, so we have divided by 100 and that can be rewritten, and when you simplify it will give you 47. So I hope you get an idea how this empirical rule can be implemented to the problem solving. Thank you.